So today we'll start one more topic of mathematics called trigonometry. So trigonometry on one hand is one of the very interesting topics of mathematics. On the other hand, it is extremely simple and very interesting. Now, to start with, trigonometry is made up of two words, trigno and metry. Trigno means triangle and metry means measurement. So basically, what we deal in trigonometry is measurements of triangle. Now, when we talk about measurements of triangle, so what all things we can measure in triangle? So, this is a triangle. So, what we can measure in triangle is the sides and the three angles. So, in trigonometry, we are going to deal with the angles of the triangle and the corresponding sides. Another thing in trigonometry is that largely we are going to deal with the right angle triangles. I hope you know what a right angle triangle is. Sorry. Yeah, this is better. So triangle where one angle is 90 degree is called right angle triangle, or also it's called as right triangle. Now before we dwell a little deep into trigonometry, let us first discuss what are the use cases of why we need trigonometry, or what is the use of trigonometry. So in trigonometry is generally used to calculate the heights of heights of large objects. When I say large objects, it could be, for example, if in case we have to calculate the height of a very large hill or a mountain, so we are going to use, for such purposes we are going to use trigonometry. The way trigonometry helps us in dealing is that if we know one side, measurement of one side and one angle, with the help of trigonometry we can find out or measure rest of the sides and rest of the angles. Now there are three basic functions which we use in trigonometry. One is sine, other is cosine, and third is tangent. As on date, these three words are going to look like kind of aliens to you because you would have not heard these words. But as we progress through this course of trigonometry, these words will get so absorbed in you that you will feel that as if you have been knowing these sine, cosine, tangents for many years. We'll further make some videos where we will explain the meaning of sine, cosine, and tangent. Now, this sine is actually written as sin, not sin, but sine in short. This is written as cos, and this is written as tan. Now, to understand this, what we will do is that we will take an example of a right angled triangle. So let's make a fresh triangle and make a little neater one. Yeah. Let's name the three points as vertices as A, B, C. Now this sine, cosine and tangent they are nothing but they are the ratios of the various sides of the right angle triangle. Now how we represent sine as, okay, one more thing is that this angle and this word you're going to hear a lot or use a lot in trigonometry is theta. So the angle which this base makes with the hypotenuse or hypotenuse makes with the base is called theta. So theta you can just think is an unknown angle. The value of the angle which you don't know. Okay, so the way we represent various variables as x, y, and z in quadratic equations or linear equations. Similarly, in trigonometry, we are going to use a standard notation of theta for any angle which is unknown or which we have to find it out. You can use any other alphabet also, okay, but the general notation is theta. We'll be using various other alphabets also in place of theta time to time, but generally we are going to use theta, a Greek alphabet theta. Now these three functions which we discussed, sine, cosine and tangent, these are nothing but as I told you, they are the ratios of the various sides of the triangle. Now for example, this sine. Okay, so before I discuss the ratios, I'll tell you there are two mnemonics which are generally used to remember. One is something which I'm really fond of since my own high school days is Pandit, Badri, Prashad, Har, Har, Bole. I repeat, it's Pandit, Badri, Prasad, Har, Har, Bole, where this P stands for perpendicular. In our example, it is AC. This B, Badri, it stands for base, which in our example is AB, and H stands for, correct, hypotenuse. And in our example, it is BC. Now, it's so difficult to draw a straight line when you're doing it after so many years. But you've got line tool to our help. Okay. Now, where's the other here? The sine of theta. Now remember, I said in place of theta you can use any alphabet. But what you have to understand is whatever notation you are going to use, this theta will always be the angle which base and hypotenuse together will form. I repeat, theta, when we talk about sine theta, then it will be always the angle which base is going to form with hypotenuse or hypotenuse is going to form with base. Now for example, if in case we take say this angle as theta, then you have to rotate the triangle such that AC becomes the base and BC continues to be a hypotenuse. So you can just imagine that this is a large object of whose height we have to find it out, and there is a person standing here. From here he is looking at the top of the object. So this will become hypotenuse. So this angle which the person will form with the ground at which he is standing will be the theta. Okay. So in our example we are taking AB as the base, AC as the perpendicular, and hypotenuse as BC. The sine of theta is perpendicular over hypotenuse. So this Pandit, Badri, Prashad. So Pandit, Badri, Prashad, all three of them will come in respective numerators. Har, Bole, H, and B will come in respective denominators. So sine theta becomes perpendicular over over hypotenuse. Cos of theta is base over hypotenuse. I repeat, it's base over hypotenuse. And this tangent of theta is perpendicular over base. Now, when you are going to, maybe in your books or when you are going to watch the videos of some other educators, you may find a different mnemonic or a way to remember this. Now, this line, this AB is what? This is adjacent to this angle. What is this? It is adjacent to this angle. So this is also called adjacent side. And this anyways BC is hypotenuse, so it becomes, but we were discussing about perpendicular, right? Yeah, so my mistake. So we are talking about perpendicular here, right? So this is this side, this is what? This is opposite to this angle. I'll just mark a line from here. Yeah, this is the opposite side. So this is the opposite side. So this becomes opposite over hypotenuse. Base is adjacent over hypotenuse, and this is the perpendicular, which is our opposite, and base is adjacent. So this gives us another mnemonic, which is so ka toa. Which means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, to be very frank, gets very confused with this opposite, adjacent, etc. So I prefer to use Pandit, Badri, Prashad, Har, Bole. Now let's take an example. How do we use it? Now, so we'll redraw the example of right angle, which we right triangle, which we took. Okay, so this is A, this is B, and this is C, and the angle which it forms is theta. Now, assuming that so what do we take? Say hypotenuse is 5. This is 4, and this is 3. Now this is being a right triangle. Triangle is 5, 4, 3. This must satisfy a Pythagoras theorem. So our Pythagoras theorem states what? The square of hypotenuse should be equal to the squares of sum of the two sides. So yes, so here it is 25, here it is 16 plus 9, and hence this is also 25. So our figures are correct. So here sine of theta is what? Sine of theta is perpendicular over hypotenuse. So here in our case is going to be 3 over 5. What am I doing? Why I am committing mistakes repeatedly? Okay, so it is perpendicular. Perpendicular is what? 4. And hypotenuse is what? 5. So 4 over 5 is the sine of theta. Then what is going to be cos theta? Cos theta is what? It is adjacent over hypotenuse or base over hypotenuse. So base is what? 3. The hypotenuse is what? 5. So this is our and third function is tangent. Come on, what is tan theta? Tan theta is perpendicular over base. What is perpendicular? 4. And what is base? 3. So this is the tangent of theta. Now, I'm not sure whether you have been able to find out the relationship between sine, cos and tan. Just understand this. Here sine of theta 4 by 5, cos theta it's 3 by 5, tangent theta 4 by 3. So if you look at these sine and cos carefully, and we can find a way out whereby the 5 goes with 5 or 5 cancels 5 and then we get result as 4 by 3. How will you get it? Take sine theta divided by cos theta. What will happen on the right hand side? What is sine theta? 4 by 5. It gets divided by what? 3 by 5. And when we take reciprocal inverse of it, it becomes 4 by 5 into 5 by 3. 5 cancels 5, which gives us the result, which is 4 by 3. And guess what? 4 by 3 is what? 4 by 3 is our tan theta. So it means sine theta over cos theta is equal to tangent theta. So congratulations, finally we have been able to derive our first result. And if you know how to derive the results or the formulas, then I can tell you, you need not memorize or cram all those about 100 plus formulas which we are going to learn in trigonometry. Let's take one more example. What do we take? Actually, on the fly I can create the values, but the problem is that I am looking for where I should have the values of these ratios also. But anyways, I am not having the trigonometric table right now in front of me, sine cos table. So let's take an example where what do you take? Say let's take this side as 2. Let's take this side as 3. So what is going to be our hypotenuse? 2 square plus 3 square. which is equal to 4 plus 9, it's equal to 13. So hypotenuse will be root of 13. Now, if this is the angle theta, what happens to our sine? What is our sine of theta? So let us write it again here. Pandit, Badri, Prashad, her, excuse me, Bole. So it is perpendicular over hypotenuse. So what's the perpendicular here? Yeah, this time no mistakes. 3. And what is the hypotenuse? Root of 13. I'm still learning to write on this tablet. Yeah. What is going to be cos of theta? Which will be base. What is base? Base is 2. And hypotenuse. What is hypotenuse? Root of 13. Correct. Very good. Third, tangent theta. So two things. One is that we can find it out from this perpendicular base. Second thing is that we can always divide sine theta by cos theta. So let's take here perpendicular base. Now perpendicular is what? Or in SOHCAHTOA, opposite is what? It is 3. Base is what? 2. Look, you can actually make it out from here itself. Third, when sine is going to be divided by cos, 13 will cancel with root 3. Root 13 will cancel with root 13. 3 will continue to be in numerator and 2 will come in denominator. So, quick check to see whether our measurements are correct or not. Now, what we'll do is that let us take our first example. This example. And we'll change the measurement of theta. So the sides are 4, 3 and 5. So 4 now will become the base and 3 becomes the correct perpendicular. Then we'll see how it is going to be, how it will change. So we'll try and make a little neat looking triangle. Yeah. Let's make base a little long. Yeah. Cool. So our base now is 4. Our perpendicular now is 3. And hypotenuse continues to be 5. So this becomes theta. So what we have done is that we have just rotated the triangle. So if you see here, our perpendicular earlier was AC. Now the AC has become base. The base was AB and AB has become perpendicular. So what has happened is that now we are looking at it from this point. So we have this as theta. So just to avoid any confusion, we are not going to call it theta. We'll call it, say, theta dash. Now, what is going to be sine of theta dash? It is perpendicular over hypotenuse, or so opposite over hypotenuse. Three over 5. What is it going to be cosine of or cos of theta dash? Yeah, tell me. It's base over hypotenuse. What is base? Base is now 4. 4 over 5. Again, what is going to be tangent of theta dash? Tangent of theta dash. So again, we can use this perpendicular base, or we can also use sine theta or cos theta. So it is going to be perpendicular over base. So now you can see the moment we change the angle theta, that from where we are looking at, our calculation changes. So this sine becomes cos, cos becomes sine, and tangent is becomes inverse of what it was earlier. Now, I guess you solve few more questions from your book, and just remember either Pandit, Badri, Prashad, her, bole, or you can use so, ka, toa. And I'm telling you, it's going to be very good practice for you, that till the time you get really, really, very well accustomed with these terms, that is, sine is perpendicular over hypotenuse, cos is base over hypotenuse, and tangent is perpendicular over base. It is going to be very, very good practice that you write these mnemonics. So in next video, we are going to do 3 more functions which we don't use that often, but again it's also used, and those 3 functions are not new. They are the functions which are derived from these 3 basic functions of sine, cos, and tan. And then we will try and derive a couple of more basic equations of trigonometry. Till then, have a good day and enjoy.